screen is visible to you?
Yes, sir.
Okay. So today we are going to start this reasoning under uncertainty. Okay. So, so we have seen this propositions or predicate logic, and then some knowledge representations like semantic nets, frames, conceptual dependencies, scripts. Okay. So here the new module starts reasoning under uncertainty. So to give you a brief about this, let's consider uh, a problem named as doorbell. Okay, so what this problem says? So consider a doorbell which rings at sharp 12 o'clock in midnight. Okay, that is in midnight. Okay, so now it arises two questions. So first question was someone there at the door? That's the first question. So if the doorbell rings at 12 o'clock in the midnight, so the first question arises that was someone there at the door, and the second is let's say someone who is in the house. Uh, let's say Mohan. So did Mohan wake up? That's the second question. Okay. So now coming to the so let's convert them to proposition. The proposition one says that uh, someone at the door. So these are two separate propositions. Okay. So this proposition says someone at the door implies doorbell, doorbell rings. Okay. So I'm writing just doorbell. So it means doorbell, or let's say doorbell ring. So if you want to, but otherwise let's see it's doorbell only. Okay. So when I'm writing doorbell, it says doorbell rings. That means if someone is at the door, so obviously he'll ring the doorbell. Proposition 2 says that if the doorbell rings, then Mohan gets wake up. Mohan wakes up. Okay, that's the second proposition. Okay, now given doorbell, what's the scenario here? We know that doorbell rings at 12 o'clock in midnight. So given doorbell, can we say that someone is at the door? So at door X. That is the question. अगर आप ये देखो, the doorbell rings at 12 o'clock midnight, and the first question was someone there at the door? So in proposition, what it says that doorbell rings, so that we know, but from this, can we interpret that someone is at the door? That's the question. Okay. So if you see this proposition, proposition number 1, so it says that someone is at the door. If someone is at the door, then doorbell rings. But can it be used for to answer this, that if doorbell rings, that then someone is at the door? So someone can answer. So can we interpret this? हमें ये प्रपोजिशन पता है, ठीक है, और हमें ये पता है कि हमें ये दिया हुआ है. So if you carefully say it, so if you consider this as P, this as Q, that means P implies Q is a proposition, and instead of, if you know P, so obviously you can conclude Q, that is modus ponens, if you remember. But here what's the case? P implies Q is a proposition, and you know Q, and you want to conclude P. So can we do so?
No, sir.
No. Actually, this type of reasoning is known as deductive reasoning. डिडक्शन हो रहा है, एक प्रॉपर रूल है, ओके। बट जहां पे इस टाइप से होता है P implies Q, and from this, and Q is given, and from Q if we infer P, this type of reasoning is known as abductive reasoning. ठीक है, as per the rules this is not a deductive reasoning, but what abductive reasoning says, that see the real scenario कि if doorbell rings, okay, as per the rule, ऐसा कोई रूल नहीं है कि अगर कोई डोरबेल रिंग हुआ है तो कोई डोर पे होगा ही होगा, बिकॉज कुछ और भी रीजंस हो सकते हैं डोरबेल बजने के। बट if you see most of the times, there someone is at the door, then only doorbell rings, okay। so real time scenarios में अगर हम देखें, so अगर डोरबेल रिंग हुआ है तो 90%, 95% this would be true कि someone is at the door, okay। so this type of reasoning is known as abductive reasoning. That's the first point that comes under this reason under uncertainty, okay। but why this abductive reasoning, why it is known as abductive reasoning is because the doorbell might start ringing due to some other reason. For example, let me, due to some short circuit in the bell, शॉर्ट सर्किट कुछ ऐसी प्रॉब्लम हो जाती है, वो कंटिन्यूस रैंक करती रहती है। विंड हो सकती है अगर आपकी बेल उस टाइप की है जो विंड से रिंग हो सके, या इसके अलावा देयर कुड बी सम काइंड ऑफ एनिमल्स, okay। so there could be other reasons also, okay, but most of the times yes, we can infer P from here, okay। that's why this reasoning is not deductive, this is not completely certain, okay। that's why this is known as abductive reasoning. That's the first point. Now coming to second point. Now, given doorbell, can we say Mohan wake up? That's the second point. Okay. So if you see the proposition number two, so proposition number two says that if doorbell rings, so Mohan gets wake up. Okay. So doorbell implies Mohan wake up. That's a proposition. That's why. So can we now answer this question? So is this abductive reasoning or deductive reasoning?
Deductive.
Deductive. So this is deductive reasoning here. Using deductive reasoning, we can say yes, Mohan wakes up. Okay, but this would be true. This would be true if and only if this proposition two is always true. Okay, if you see, it might be the case in general that Mohan might be at some point of time he's very tiring or he's in very deep sleep that even the doorbell rings, Mohan doesn't wake up. So that could be the case at some time. Okay. So here, if this proposition holds, so see, as of now, when we see in previous classes about this propositions, so they were we have already considered that if the proposition is given, so that is a certain that is said to be with complete certainty. But when we are studying reasoning with uncertainty, so we are considering the some real cases that could be possible. Okay, so this is the proposition that if the doorbell rings, Mohan gets wake up. But when you see a real time scenario, that then it might be possible that at some point of time this may not hold true. The doorbell rings, but due to Mohan, let's say, is in deep sleep, so he doesn't get wake up. Okay, so we certainly say that yes, if if doorbell rings, then Mohan gets wake up if proposition 2 is always true, if it holds with complete 100% certainty. Okay, so that is the second point. Now coming to the third point, so that means we now we have so, so for both the questions, we saw two things. The first thing is uh, this question can be answered using abductive reasoning, although the second question can be answered using deductive reasoning, but if the proposition holds with complete certainty. Okay, that means the both of these questions cannot be answered with 100% certainty. दोनों में कुछ ना कुछ एक परसेंट चांस है कि इतने परसेंट चांस है कि ये ट्रू होगा, या मतलब there is no 100% guarantee that this always we can answer this question with a certain answer. Okay, so proposition 1 में क्या प्रॉब्लम थी? When we are trying to answer the first question, so हमने वहां पे abductive reasoning क्यों लगाया? क्योंकि proposition 1 was incomplete. Why it was incomplete? Because the proposition says that if someone was at the door, then doorbell rings. This was the proposition. But in real time scenarios, it could be possible that, although very rare chances, but it could be possible that doorbell can ring due to some other reasons. Okay, that's why the proposition 1 could be made complete by appending the other conditions. For example, either someone is at the door, or there is a short circuit in bell, or there is a wind, or there could be other reasons. Then, if any of this condition holds, then it might be possible that doorbell. Okay, so now you can see that on the left side there are infinite number of reasons possible. Okay, so that means number of clauses here is large or huge or even infinite. Okay, and uh, what is the second problem? What is the problem in proposition 2? So proposition 1 was incomplete, and when we make it complete, so it could have infinite number of conditions on the left side. On the other hand, proposition 2, we said that it is often true. Proposition 2 was often true, but it is not a tautology. Tautology, you remember? So tautology, which always is true. For example, P or not P. Okay. For example, mortal X or not not. So uh, uh, these type of statements are tautology. because they are always true. Okay, so now is there any way out, like how we can handle such problems, such uncertainty? Okay, so and these type of problems are very common in real life. So in AI, we often need to reason under such circumstances. Okay, so there are some conditions, and we have to conclude something, or we have to reason under the given circumstances or conditions or uh, uh, clauses. Okay, so we solve it by proper modeling of uncertainty and impreciseness. Okay, let me write it. So in AI, we often need to reason under such circumstances, and we solve it by proper modeling of uncertainty and impreciseness. Okay, and then developing appropriate reasoning techniques. Okay, so uncertainty तो आपको पता चल गया कि क्या है, but what I mean to say by impreciseness? Can someone guess? Impreciseness क्या हो सकता है? जैसे uncertainty तो आपको पता चल गया कि we are not 100% sure, or based on that conditions we can't conclude this with 100% certainty. That is the concept of uncertainty here. But what I mean to say by impreciseness?
So maybe what the answer we select, how close it is to the actual answer.
Yes, usually in many cases we say uh, there is a huge crowd outside, or uh, the temperature is very high, or today the sunlight is very low. Okay, so we are not precise. हमें नहीं that man is very tall. कितना टॉल है, देयर इज नो प्रिसाइज इंफॉर्मेशन. ओके, अब आप कहने लगो कि जिसकी हाइट लेट्स से 5'5" से ज्यादा है वो टॉल है, किसी के लिए 6 से ज्यादा है तो टॉल है. सो देयर इज नो प्रिसाइज इंफॉर्मेशन. ओके, एंड यूजुअली आपने देखा होगा रियल टाइम सिनारियोज में जनरली हम ऐसे बहुत सेंटेंसेस यूज करते हैं जहां पे हम इम्प्रिसाइज होते हैं. हम एक अप्रोक्सीमेट एक ऐसी टॉल मतलब सामने वाले को समझ आ गया कि हाँ लंबा है, कितना नहीं पता, प्रिसाइज इंफॉर्मेशन कोई. दैट इज सेड टू बी हियर impreciseness. Impreciseness उस चीज को यहाँ पे रेफर किया जा रहा है. ओके, ओके, सो now let's see what are the sources of uncertainty. हम सबसे पहले अब uncertainty देखते हैं. So what could be the sources? So number one, first could be that implications may be weak. Okay, when I say implications may be weak, so that means doorbell, and this I'm appending point 8, wake Mohan. Okay, so this is that some kind of certainty factor, or basically we have quantified this. So quantification of frequency of bell with which the rule applies. That means अगर डोरबेल की आवाज और उसकी फ्रीक्वेंसी 0.8 से ज्यादा हुई तो मोहन वेकअप होगा with complete certainty. otherwise it could be uncertain, or there are 80% of chances that agar doorbell rang, so Mohan gets wake. In the simple way, just consider this point here that 80% chances है कि ये certainly true होगा, ये hold करेगा. Okay, and as I told you that imprecise imprecise language कौन सी होती है, जहाँ पे हम ये यूज करते हैं often, rarely, sometimes, tall, etc. Okay, so this type of information we need to quantify. Okay, and then we have to design the rules, design design rules, then according to these quantified values. Okay, okay. Now coming to the second source, so precise information may be too complex. Okay, for example, as we have seen कि वहां पे जब हमने डोर वाले पहली प्रपोजिशन को कंप्लीट करने के लिए हमने एंटीसीडेंट्स जोड़े थे, ऐड किए थे, so it was huge, short circuit and wind and so on. This implies doorbell. Okay, so you can see here that there are too many antecedents or consequent. Okay, there could be incomplete knowledge also. So we may not know or guess all the possible antecedents or consequence. जैसे कि अगर मैं ये कहूँ that the doorbell rang due to some spooky reason, some unknown reason. So it means that we may not know or guess all possible antecedents or consequences. That is said to be incomplete knowledge. Okay. Third source of uncertainty comes as conflicting information. Conflicting information किसे कहते हैं? So usually मेडिकल फील्ड में ऐसा बहुत देखा जाता है. आपको कुछ सिम्टम है, आप you visit one type of doctor or you visit a physician. So he said that आपके सिम्टम्स को देखते हुए ये लग रहा है, ये टेस्ट वगैरह कराओ. टेस्ट देखा उसने, so he probably uh, uh, he probably diagnosed some kind of disease. Okay, then you went to some other physician or some kind of specialist of something. Okay, so he said no, that is not the case. As per my belief, this is the case that आपको ये हुआ. Okay, so there could be and I hope you know that this is a very common scenario in when we visit different doctors with the same symptoms with the same patient. So the different doctors may have some conflicting judgment or conflicting diagnosis. Okay, This type of information is known as conflicting information, and that is a major source of uncertainty in such type of information. Okay, so for example, experts often provide conflicting information. Okay, so ऐसे cases में we need to quantify their measure of belief. दैट मीन्स अगर कोई डॉक्टर कह रहा है कि मुझे ये आई एम डायग्नोसिंग दिस इन यू, मुझे ये डिसीज लग रही है, सो कितना परसेंट बिलीफ है उसे ये है. ओके, एंड दिस लेड टू समथिंग नोन एज propagation of uncertainties. Now what is this? Propagation of uncertainties किसे कहते हैं? For example, let's say अगर मैं ये कहता हूँ tomorrow would be a sunny day, and I'm saying 0.6, that 60% belief, or I have 0.6 belief that this would hold true. Okay, secondly, I'm saying that tomorrow would be a warm day, and that's a pointed belief. Okay, so when using this information, if I say that tomorrow there would be a sunny and warm, then what could be my belief? What could be the number here? So if I have this much of belief that tomorrow would be a sunny day, if I have this much of belief that tomorrow would be a warm day, then how much belief, or with how much certainty I can say that tomorrow would be a sunny as well as warm day? So that that is even less certain than this one as well as this one. Okay, so this said to be propagation of uncertainty, कि ये भी अनसर्टेन है, ये भी अनसर्टेन है, तो इनका एंड यानी कि इनका कॉम्बिनेशन तो और ज्यादा अनसर्टेन होगा. So that is known as propagation of uncertainty. Okay, so that is in absence of interdependencies, propagation of uncertain knowledge increases the uncertainty of conclusion. Okay. Okay. So basically, in other sense, we can see here that, for example, there is a implication that if A then B, and we say with one certain that we are completely certain that if A then B, okay, and if B then C, this is also 100% certainty, we can say. Now, if we know that A is true or A holds, ओके, सो ये ए अगर होल्ड करता है, सो विद 100% सर्टेनिटी बी होल्ड करेगा, एंड इफ बी होल्ड करता है तो 100% सर्टेनिटी के साथ सी होल्ड करेगा. ओके, तो सी होल्ड करेगा कंप्लीटली, वी कैन से. बट on the other hand, let's say if A implies B is 0.7 and B implies C, it's 0.6, let's say, and we say if A holds, then A से B imply करेगा with 70% chances, and if B holds then C holds, this would be even more lesser chances than previous B. This is said to be uncertain, क्योंकि B का होना, अगर A hold किया है agree, लेकिन B hold करेगा या नहीं, इस this is uncertain, and if B hold करेगा तो C hold करेगा या नहीं, that is more uncertain. So this is known as propagation of uncertainty. Okay. Now next, outcome is certainty factor. Certainty factor किसे? So what do certainty factors means? Okay, so let's see the definition. The certainty factor, it is an expert's estimate of degree of belief or disbelief in an evidence hypothesis relationship. E implies H. So it is a subjective probability estimate provided by the expert from his or her experience. Okay, so basically, if this E is referring for the evidence, and this is for hypothesis. Okay, so that means it's an expert's estimate of degree of belief कि कितना एक एक्सपर्ट की अगर हम बात करें तो अगर कुछ एविडेंस प्रेजेंट है सो हम उस हाइपोथेसिस को कंक्लूड कितने डिग्री ऑफ बिलीफ से या डिसबिलीफ से कर सकते हैं. ओके, so from this there comes as two terms measure of belief which is known as MB and H given E. That means what is the measure of belief for hypothesis H given the evidence E, and same as come as measure of disbelief MD of hypothesis H given evidence E. कहीं कहीं आपको सिंपली इस टाइप से भी मिल जाएगा. So both are same. Okay, MB H given E or MB H comma E both are equal. Okay, so when I'm saying that if the event evidence is given, then we can conclude the hypothesis with 0.6 belief. So that means the corresponding measure of belief is 0.6. Okay. Now let's see some relationships between them. For example, there is a evidence E1, and if E1 is present, then we can conclude hypothesis with 0.6 belief. Let's say, okay, and and for example, let's consider this that if E1 is present, that 0.8 is the measure of belief. Okay, that means measure of belief of hypothesis H given E1 is 0.8, and measure of disbelief of hypothesis H given E1 is, let's say, 0.6. Okay, so how we can find out the certainty factor? Certainty factor of H given E, that is equal to the measure of belief H given E minus the measure of disbelief H given E. So that is the. Okay, so here we can conclude that hypothesis given E1 would be equal to 0.8 minus 0.6, that is equal to 0.2 for this case. Okay, now there are there could be, consider this case. Okay, so this case says that several rules contribute to one hypothesis. Okay. Second case, A and B. That means what is our belief in several propositions taken together. And third case is A implies B implies C. So this says that what is our belief in the result of rule chaining. Okay. Okay. So now see what is certainty algebra. So there are some relations between them. So measure of belief H given E would be so measure of belief H given E would be greater than 0 and less than 1 if measure of disbelief H given E would be 0, or similarly measure of disbelief H given E would be greater than 0 and less than 1 if measure of belief H given E would be equal to 0. And this certainty factor H given E is equal to measure of belief H given E minus measure of disbelief. Now, if we have two evidence, for example, so measure of belief H given E1 and E2. Okay, so this would be equal to 0 if measure of disbelief H given E1 and E2 equal to 1. Okay, and this would be equal to measure of belief H given E1 plus measure of belief H given E2 1 minus measure of belief H given E1 other. Similarly, measure of disbelief H given E1 and E2 would be equal to 0 if measure of belief H given E1 and E2 equal to 1, and it would be equal to measure of disbelief H given E1 plus measure of disbelief H given E2 into 1 minus measure of disbelief H given E2. Pausing for 2 minutes, see this formula and let me know if this is clear to you or not. तो सी दिस विद अ सेट। ओके, अगर आपको क्लियर नहीं है तो एक और तरीका है, मैं आपको अच्छे से इससे समझा देता हूँ। कंसीडर दिस टू बी टू सेट्स। ओके, कंसीडर दिस सेट एज measure of belief h given e1 and measure of belief h given e2। ठीक है, ये एक सेट है, ये एक सेट है। ठीक, सो एंड देयर इज सम पोर्शन हियर। सो अगर हम इन दोनों को ऐड कर रहे हैं, सो व्हेन वी आर एडिंग दिस एंड दिस, सो यू नो एज पर द सेट थ्योरी दिस गेट्स एडेड ट्वाइस, दिस गेट्स एडेड ट्वाइस। ओके, सो ये पोर्शन जो है दिस मच, this portion, this is nothing but measure of belief h given e1 into measure of belief h given e2, ये वाला जो पोर्शन है। सो अगर मुझे इसका यूनियन निकालना है, अगर मुझे इसका यूनियन निकालना है, तो मैं क्या करूंगा, मेजर ऑफ बिलीफ h गिवन e1 प्लस मेजर ऑफ बिलीफ h गिवन e2 माइनस इस पोर्शन को मुझे एक बार माइनस करना पड़ेगा क्योंकि ये दो बार ऐड हो चुका है। तो दिस कम्स एज माइनस mb h गिवन e1 इनटू मेजर ऑफ बिलीफ h गिवन e2। और अब इन दोनों में से अगर आप इसको कॉमन ले ले तो ये सेम है, 1 माइनस measure of belief h given, and this is same as, okay, is this clear?
Sir, in the second like measure of disbelief, it should be
Sorry,
like
yeah,
it should
हाँ
be
हाँ, it
even.
should be there, oh yeah, yeah. Wait. Yes, it's coming यहाँ पे ना,
Yes, sir.
this concept correct। Okay, what else? Now if we have combination of hypothesis, okay, so that means mb h1 and h2 given e, if hypotheses are more than one, then measure of belief would be minimum of measure of belief of h1 given e, comma measure of belief h2 given e, जो उनमें मिनिमम होगा उसको कंसीडर करेंगे। ओके, और अगर यहाँ पे हुआ h1 और h2 गिवन e, तो यहाँ पे मैक्स कंसीडर करेंगे। Okay, and in the same in the same way we let me do, okay, so यहाँ पे md same, okay, so it says that for example if we have, let's say, this evidence e and uh, and let's say measure of belief यहाँ पे h1 के लिए 0.7 है और h2 के लिए 0.6 है, this measure of belief। Okay, so uh, फॉर एविडेंस E, मेजर ऑफ बिलीफ H1 एंड H2 के लिए कितना होगा, एंड H1 और H2 के लिए कितना होगा. So H1 and H2 के लिए पहला फॉर्मूला मिनिमम, दिस कम्स एज 0.6, एंड और के लिए मैक्सिमम, दिस कम्स एज 0.7. Okay, so let's stop here today. So we'll continue this tomorrow you have class test, so we'll continue this with Monday. If you have any doubt, you can ask. Please attend your roll call. 205.
Present, sir.
6.
Sir, he has written in the chat box.
Yes, 7.
Present, sir.
8.
Yes, sir, 208 present.
9. 10 is present. 11.
Present, sir.
10 present,
12.
sir.
Yeah, 10 is present. 12. 13.
Sir, 13 has written in the chat
Yes.
box.
Okay. 14.
14 present, sir.
15. 16.
Present, sir. 16.
17.
Present, sir.
18.
Present, sir. 18.
19.
Sir, he is written in the chat box.
Okay. 20.
Present, sir. 20.
21. 22.
Present, sir.
23.
Present, sir. 23 present.
24.
20 present, sir.
25.
25 present, sir.
26.
Present, sir.
27. 28.